So today what we're going to be doing is graphing a quadratic in standard form. Again, but in this case, the quadratics aren't going to be as friendly to graphing as they were last time. This is going to be when we have graphing a quadratic that doesn't have any real roots, which means it's going to curve away from the axis and never actually touch it. This means we're going to have to find the vertex using a different method. We're going to learn about completing the square here in a future lesson, but for today, we're just going to learn two formula which are going to always find us the vertex, given it's in ax squared plus bx plus c format. This means that we're going to have to take x equals negative b over 2a, and remember, this is in the form of ax squared plus bx plus c. So for my b, I'm looking at the second number. For my a, I'm looking at the front number. And remember, if there's nothing there, we assume that there is a 1. Then we're going to plug whatever we get for this into our function, reevaluate, which will give us our y coordinate. Now, this is built off the idea that if I were to try and hand factor this, I would be having to come up with factors of, let's see, negative 9 times negative 1. So negative 9 times negative 1. That would be positive 9. I need to find factors of positive 9, which means sum, that add up to 6. So I have 1 and 9, 3 and 3. Lo and behold, we have 3 and 3, which means that we have, cool, so we can actually factor this one. Let's go ahead and factor it and see what we get. Well, when we factor this one, I'm going to split this into negative x squared minus 3x minus 3x minus 9. In this case, I'm going to pull out negative x, and I'm going to pull out negative 3. So negative x, negative 3. And that's going to give me, let's see, if I divide that, that's an x plus 3. And same thing over here, x plus 3. Ooh, which means I can pull out an x plus 3. So I have x plus 3. And then I have a negative x minus 3. And we know basically that we're setting both of these equal to 0, which means my x plus 3 has to be equal to 0 for my root 1. And my negative x minus 3 has to be equal to 0 for my root 2. I subtract 3. Boom, there's my first root. I add 3. And I divide by negative 1. And we run into our problem. When we try and graph this using the root method, which means we're not graphing the vertex, I end up with the same root. So 2, 3, negative 3, and negative 3, which gives us a problem because that means that that root is our vertex. This is going to curve away from the axis, and we don't know whether or not it's going to curve up or curve down, or how it's going to curve, where it's going to curve, what's going on. So the only way that we can figure out another point to plug in there is we could try and plug in our y-intercept, which means I can take 0 and plug that into the equation just to give it a second point. And so let's give that a shot. So I'm going to plug in 0 and say f of 0 is negative 0 squared minus 6 times 0 minus 9. It's going to be f of 0 is equal to cancel, negative 9. Okay. Seeing as I can't fit that on there, I'm going to make my y by 2's. My x, it's got to be by 1's, which means that's going to be 2, 4, 6, 8, 9. Awesome. And that means that the magic of this is that if I were to draw my axis of symmetry through here, we know that that reflects So there'd be another point 1, 2, 3 to the left that would curve through there. And what we're going to see is that our new approach is going to be a little less cumbersome than this. We're just going to find the vertex and we're going to find the y-intercept. Let's see how easy it is to find the vertex of this same problem. And we're going to do that over here. So I'm not actually going to be doing this problem. I'm going to be resolving number 1 using our new process. So I'm going to find the vertex using negative b over 2a. So negative b over 2a. What is my b? Well, negative 6. What is my a? That's negative 1. So negative negative 6 is 6. 2 divided by negative, or 2 times negative 1 is negative 2. 6 divided by negative 2 is negative 3. Hey, so far so good. So I found the x part of my vertex. Let's find the y part of my vertex. And to find the y, I plug in my x, which means if we remember evaluating a function, I'm going to plug that thing in to the function. So I'm going to say, okay, f of negative 3 is equal to negative minus 6 minus 9. And I'm actually going to plug in a negative 3. So I get negative 3 squared, which is 9. Negative 3 times negative 6 is positive 18 minus 9. 18 minus 9 is 9. Negative 9 plus 9 is 0. So that means my vertex is at negative 3, comma 0, which would put us right back at that spot. And we can see that this relies on a little less, how should we say this? A little less of a cumbersome approach. This is much cleaner because many people just like the simplicity of let's find the x and plug it in. When we factor, albeit the factor will give us the zeros, if we just want to graph it and find where the maximum point is, let's just plug it in and find the vertex. Once we find the vertex, the second follow-up is we do the same thing that we would do right here, and we would plug in our 0 to find our y-intercept. And we would get f of 0 is negative 9. And we graph that. So like I said, if you like a cleaner approach and you need to find the vertex, you need to find that maximum point, most importantly, go for there. Because we lucked out and this happened to be able to be factored. So let's try the new approach on number 3. Let's find the vertex and then the y-intercept. So to find my vertex, I'm going to say x equals negative b over 2a. My b is 6, my a is 1. So negative 6 over 2 times 1. It's going to give me a negative 6 over 2, or again, I get another negative 3. Let's see where this goes. So I'm going to take that and I'm going to plug it into the equation. F of negative 3 is equal to order of operations. Negative 3 squared is 9. 6 times negative 3 is negative 18. 9 minus 18 is negative 9. And this is 0. Oh, so this looks like it might be another reflection of what we just did. So let's plug in the negative 3 and see where we go. So I have my point right there. I know that's my vertex, which would have saved us a lot of time right here because we would have gotten 2 roots again of the same thing. But I found my root, or I found my vertex. Now what I'm going to do is I'm going to find my y-intercept as a second point that I can graph. So f of 0 is, let's plug in my 0 into everything. 0 squared, 0, 9. Boom. Again, I'm going to have to do this by 2's, which means it's right there. And I know the fact that it's going to reflect across my axis of symmetry, which means there's another point right over there that's going to curve through. So if I curve up to the right, I'm going to curve a mirror image to the left. Like I said, there we go. And so because this touches the axis, we'll actually be able to factor this. Anytime this touches, you're able to factor it. So let's try it on this one. This one might not be so lucky. So what I want you to do is I want you to pause the video. I want you to try the new approach and unpause it when you're done and see how you did. Okay, let's give it a shot. So with this one, I'm looking at this and I see factors of 14. I can't find any factors of 14 that would sum to 6. So I know there's no possible factors, which means that this is either going to be irrational or it's not real. So let's try it out. So x is negative b over 2a. And so my b in this case is negative 6, and my a is negative 1. So it's going to give me a 6 over negative 2. I get another negative 3. Really need to change up these questions a little bit. But regardless, I'm going to plug in my negative 3 into my function and evaluate it. That's going to give me negative 3 squared is 9, so I have a negative 9. Negative 6 times negative 3 is positive 18 minus 14. Let's see, negative 9 plus 18 is going to be 9 minus 14. 9 minus 14 is negative 5. Okay, not too bad. But now, what we've seen in the previous ones is that when I graph this point, my other point bounces off my graph. So I'm not going to graph my vertex just yet until I find my y-intercept. So let's go ahead and find the y-intercept by plugging in 0. So if I plug in 0, cancel, cancel, f of 0 is negative 14. Ooh, I'm very glad I didn't, because that means that I'm going to have to stretch this just a little bit. Let's do this by 3's, and heck, why not? Let's do this by 3's, just to keep it even. So if my vertex is at negative 3, negative 5, negative 3, negative 3, 4, 5, it's right there. And I now have another point at 0, 3, 6, 9, 12, 13, and 14. 14. And I know that if I reflect through this central line, that means I have another point right on the other side. And that will curve like this. Perfect. So yeah, if we tried to factor this, it doesn't touch the x-axis at all. We would have been waiting a very long time to find some combination of numbers to find when this crosses the x-axis. So this saved us some time. Let's do one more. So here, I'm looking for factors of 8 that add up to 4. I have 1 and 8, which add up to 9, and I have 2 and 4, which add up to 6. So I don't have any factors. So I'm going to have to use the other method. Which means I'm going to have to plug in my negative b, which is 4, my a, which is a 1. So if I have a negative 4 over 2, negative 2. Hey, we got something other than a negative 3. Progress. So let's plug in that negative 2 and see what we get. Plug in the negative 2. That's going to give us negative 2 squared is 4. 4 times negative 2 is negative 8, plus 8. I know those cancel out, so it's just 4. So there's my vertex, negative 2, comma, 4. And then as we did earlier, we're going to go ahead and we're going to plug in our y-intercept, just so we can have some sense of scale. Cancel, cancel. So my y-intercept is 8. So negative 2, 4, and 8. I think I'm going to be able to get away with scaling this by a factor of 2. So for my vertex, I'm going to go negative 2 to 4. And I have my vertex. I know my y-intercept is at 0, 2, 4, 6, 8. And I'm actually going to draw my axis symmetry in green, because I feel like the orange on red is a little misleading. So I know that if I have a point 1 to the right, I'll also have a point 1 to the left. Boom, there we go. And so just like before, this actually doesn't touch the axis. So if we tried to factor that, we'd be waiting a very long time. Okay. Last question. Go ahead, pause the video, try out number 9, and see how you do when you unpause it. Okay, let's take a look. I'm going to assume now, just by the trend we've seen, that factors of 66 are probably not going to add up to 16. But x equals negative b over 2a. We have a better way to do this. So my b in this case is a negative 16. My a in this case is a 1. So negative 16 is positive 16 divided by 2. I get 8. Ooh. And so if I take that 8 and I plug it in, I'm going to plug 8 into my function. See, 8 squared is going to give me 64. 16 times 8, okay. Well, 6 times 8 is 48. 10 times 8 is 80. 80 and 48 make 128 plus 66. I'm going to kind of skip around this and say 64 plus 66. 64 plus 6 is 70. 70 plus 60 is 130. 130 minus 128 is 2. So my vertex is at 8, 2. Now I just need to find where my y-intercept is. And have any of you figured out the shortcut to finding the y-intercept? Well, when I plug in 0, the y-intercept, if you haven't noticed by now, when I plug in 0, it's always going to be that number right there. You notice that every one of our problems, the number that doesn't have an x doesn't get zeroed out. So when you're asking yourself, what's the y-intercept? At least when it's in standard form, it's always going to be your c term. But regardless, we need to be able to fit 8, 2, and 66. So that means I'm going to have to count more than by 10s. I'm going to have to count by, let's say, 15s. This is going to be a really messy graph. So 8, 2. So 8 is going to be about halfway. 2 is going to be just barely above the line. 66, okay, so 15, 30, 45, 60. It's going to be roughly there. And we know because if we have an axis of symmetry that goes right here, and I have a point on the left, I'm also going to have a point on the right, which is going to make this very narrow and skinny quadratic. And there we go. So today we're going to introduce the quadratic formula. Now, this is an incredibly important formula because it's going to break down a really big aspect of what we normally hand factor for, and it's going to allow us to find the roots of any quadratic, regardless of whether or not it can be hand factored. And it's based off of the idea of something called the vertex and the discriminant. And now, without getting into too complex of an analysis, the idea behind any quadratic is if I have a quadratic and I have my, let's say, drawn like that on the axis, what I know is that from my vertex, we know that this thing is symmetrical on the left side versus the right side. So if I can find that central point on the x-axis, I know that the distance over here is the same as the distance over here. Now my drawing might not be exactly, but I know that this distance is the same thing as that distance. So if I find this point and I know this distance, I can add it and subtract it from my vertex and get root 1 and root 2. So without, like I said, getting into too much of a description, too much of a lesson of that distance on a quadratic is going to be what we call the discriminant. And we find that by using b squared minus 4ac. So the quadratic formula is built off of saying, okay, I'm going to take that vertex, negative b, or 2a, and I'm going to add and subtract, add the distance to root 1, subtract the distance to root 2, but I know it's going to be the same thing both times, and I'm going to use this, the discriminant, which is going to be b squared minus 4ac. And again, let's not get too caught up in how we created that, but the idea is that we find the vertex, add the distance, and take the distance back away. Boom, we'll have each root value. So today, all of our quadratics are going to hand factor. So you could actually hand factor each one of these, but we're not going to because I want a chance to practice this where it works out nice and neat. Not all the time will it work out nice and neat, but it's a good way to introduce this topic so you can check your work when you're done. So let's go ahead and use the formula. I'm going to take x equals negative b over 2a, and I'm going to both add and subtract the discriminant, so the b squared minus 4ac. All I need to know is my a, my b, and my c. So my a is my number out front, my b is the number in front of the single x, and my c is the number without an x. So let's go ahead and plug that into the formula and see how we do. Cool. So my a here is 1. So 4 times a over 2a. My b is 8, so negative 8, 8 squared. My c is 16. And so 98% of the quadratic formula is not necessarily understanding how to create this. It's an arithmetic process to simplify what you see right here. Nothing crazier. We've got our two roots. I'm going to start simplifying it. So that's a negative 8 plus and minus 8 squared is 64. 4 times 1 is 4. 4 times 16 is negative 64. All over 2. I know 64 minus 64 is going to be 0. Perfect. And so at this point, what we're going to do is I am going to split. I'm going to split it into and x equals a negative 8 plus 0 over 2, and x equals negative 8 minus 0 all over 2. And I'm going to solve each one of these. Negative 8 plus 0 is just negative 8 over 2, which is negative 4. Negative 8 minus 0 is negative 8 over 2, which is negative 4 again. Awesome. So we notice that the discriminant here is a 0, so that must mean that my vertex has no distance between the roots, and the only way that we would get that, and let's just use this line for example. Let's say this is the line of the vertex. If my vertex was right here and it curved, I would have a positive discriminant. The only way I can get that gap to be so tight is if my two roots are on the vertex. So I'm going to see something that looks like that. Get rid of that right there. I'm going to see something that's so close that the two roots are on top of each other. And now again, you can't actually prove this by hand factoring. We're not going to worry too much about it. The idea is that, boom, we take the vertex and we add and subtract that distance, and we'll get the two roots. So what we've got right here, I need to find my a, which again is 1. I need to find my b, which here is 3, my c, which is negative 10. I'm going to plug it into the formula of vertex plus or minus the discriminant. Okay. Let's plug in our values. Let's see, negative b, which is 3, b squared minus 4 times a times c, all over 2a. And so again, most of the quadratic formula is not some complex process, it's just simplifying what you've got right here. And so this is arithmetic, and we're really confident in our skills with arithmetic. So that's a negative 4 times 10 is a positive 40. Okay. So at this point, I have x equals negative 3 plus or minus the square root of 49 all over 2. And so I'm not quite at the point where I'm going to split yet because I haven't fully simplified my graph. I'm going to come over here and say, okay, x equals negative 3. I know the square root of 49 is 7. Now I'm going to split. X equals negative 3 plus 7 all over 2. I'm getting that root, and I'm going to get x equals negative 3 minus 7 all over 2. So then I'm going to subtract the distance. So I'm going to add the distance and subtract the distance and get my two roots. That's 4 over 2. There's my first root. Over here I got negative 10 over 2, which is negative 5. Perfect. There we go. So knowing what we know, what we're going to do is I'm going to identify the A, the B, and the C. And I'm going to give you the formula, and what I want you to do is I want you to give this a shot. Pause the video and resume it when you're done and see how well you did. There we go. So pause the video. There's the formula. There's your A, your B, and your C. Plug those in and see how well you do. Let's see how we did. So in this case, I have a negative 15. I have a negative 15 squared, negative 1, negative 50, negative 1. And so here's our first catch. What a lot of you probably did was you said, okay, if I need a negative b, my b's already negative, you probably just plugged in a negative 15. But be careful, because I want a negative whatever b is. So if b's negative, I want a negative negative, which makes that a positive. The second thing that you probably did, if you weren't paying attention, was negative 15 squared. What many of you probably did was you squared 15 and you said 225, and then you made it negative. Remember, most of the mistakes in quadratic formulas are not in the process, it's in simplifying what you've got. Negative 15 times negative 15 is positive 225. And lastly, again with negative signs, negative 4 times negative 1 is positive 4, times negative 50 is negative 200. All over negative 2. Cool. So then I'm going to take that and I'm going to say, okay, x is 15 plus or minus square root of 25. And that's going to give me 15 plus or minus 5 all over 2. And at this point, I'm going to go ahead and I'm going to split. I'm going to find the distance to the right by adding it. I'm going to find the distance to the left by subtracting it. There we go. So how'd you do? Let's try it. Let's just give this a shot. These are both just further examples. Nothing crazy, just making sure our arithmetic is good. So let's go ahead and plug this in. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, my a is no longer just a 1 or a negative, it's actually a number in and of itself. Not that 1 wasn't a number in and of itself, it's just a bigger number. There we go. 13 is 4 times a times c all over 2a. There we go. So I get negative 13 plus or minus 169. Let's see. That's going to give me, well, 2 times 15 is 30. 4 is 120. Cool. And so at this point, I'm going to split. So I get x equals negative 13 plus 7, so I can get that distance to the right. I get x equals negative 13 minus 7, so I can get that distance to the left. Boom. There we go. And so if you follow that same logic on number 9, let's go ahead and knock number 9 out real quick as well. Like I said, all we're doing right here is we're just practicing plugging in our values, practicing the arithmetic involved in reducing this. Again, I notice that I'm taking a negative of a negative, which is going to end up making that a positive. So I get a positive 16 plus or minus, let's see that, I think that's 256. Okay, so 3 times 21 is 63. That's a positive 63.
4 times 60 is 240. 4 times 3 is 12. 240 and 12 make 252. I keep going. And I can actually reduce this. That's going to give me an x equals 8 plus or minus 1, negative 3. And then in this case, now that I've fully reduced everything I can, now I'm going to split. So x equals 8 plus 1 over negative 3. And x equals 8 minus 1. It's the distance to the right and the distance to the left. There we go. Compare that to see how you did, and that's it.